everyone. Today we're going to be talking about another kind of special right triangle called a 30, 60, 90 triangle. And I bet you can already guess why it's called a 30, 60, 90 triangle. Well, that's because it's a right triangle that also has a 30-degree and a 60-degree angle in it. So this is another type of special kind of right triangle that has ratios that will help you to solve for the sides of this right triangle. And you can only use the ratios I'm going to talk to you about with a 30, 60, 90 triangle. So be careful. Okay, so in the 30, 60, 90 triangle, again, this is a right triangle with a 30-degree angle, a 60-degree angle, and a 90-degree angle. Now, we need to talk about the parts of a 30, 60, 90 right triangle. So, angles in a triangle directly relate to the sides that are directly across from them. So, the smallest angle in your triangle will open up to the smallest side of your triangle. Okay, which makes sense because if it's a smaller angle, that means the angle will be opening up to the side directly across from it. So if it's a smaller angle, the side across from it will be a smaller side. Okay, so in this triangle, we have three different parts. One of the parts is called the short leg, which I've called the SL. And that is a side directly across from the smallest angle in the right triangle, which in this case is the 30-degree angle. So the short leg is always going to be the side directly across from the 30-degree angle. Okay, and it's also a leg on the triangle because it makes up one of the sides of the right angle. Now the longer leg, it's also one of the sides of the right angle, and that is the side that is directly across from the 60-degree angle. Okay, because 60 is a larger angle than 30, so the leg length will be longer than the short leg, which is across from the 30-degree angle. So the long leg will always be the side that is directly across from your 60-degree angle. And like normal, the 90-degree angle is directly across from the side that we call the hypotenuse. So the these will be the three sides that I'm referring to in your 30, 60, 90 triangle. All right, now this is the nifty ratio that goes along with solving for the sides of a 30, 60, 90 triangle. All right, we have 1 over the short leg will equal root 3 over the long leg, which will equal 2 over the hypotenuse. Now be careful, these are different ratios than when we dealt with a 45, 45, 90 triangle. So be careful. Okay, in the 45, 45, 90 triangle, the ratio was 1 over leg equals root 2 over hypotenuse. So just be careful. These are completely different ratios. So just watch yourself. The demon cats are always watching. All right, and also, you guys, something that helps me to remember these ratios, I can remember the top as 1, 2, 3. I know that the 3 is under a square root, but that might help you. So 1, 2, 3 in the numerator. Okay, also, you guys, since it is a right triangle, technically, you can still use those nifty trig ratios that I taught you about to solve for the side. So after you try out the awesome ratios that, in my opinion, are really cool, after you try those out, if you do not like them, you can always use sine, cosine, and tangent to help you solve for the sides of this triangle since it is a right triangle. All right, so in examples 1, 2, 3, and 4, we're going to find all the missing sides and all the missing angles in the following 30, 60, 90 triangles. It's going to be super fun. All right, well, let's get started on example 1. All right, and let's hope that my screen doesn't freeze permanently. Come on, screen. Sorry, guys. I don't know why it always does this. See if I can fix it. All right, here we go. Okay. So, example 1, I have the right triangle drawn. I'm going to show you how to solve for the missing sides of this 30, 60, 90 triangle, which I'll explain how I know it's a 30, 60, 90 triangle. All right, and then I'm also going to show you only in example 1 that you can also use trig to still solve for the sides of your right triangle. So let's get going. Okay, so here are the ratios that we're going to be using to help us solve for the missing sides. Now, first of all, I have a 90-degree angle in my triangle, which means this is a right triangle. Okay, so if I have a 90-degree angle, 180 minus 90 is 90. And then 90 minus 30 is 60. So I know that the missing angle in my triangle is the 60-degree angle right here. So look at that. Holy hot dog. It's a 30, 60, 90 triangle. Okay, so when you have a 30, 60, 90 triangle, that is when you can use these ratios to help you solve. Okay, now the first thing I do is I like to label, well, which side is the short leg, which side is the long leg, and which side is the hypotenuse. Well, the short leg is the side that's directly across from the 30-degree angle. So the X right here is the short leg. The long leg is the leg that is directly across, or the side that is directly across from the 60-degree angle. So this is the long leg. And then the hypotenuse is the side directly across from the 90-degree angle. Whoa, look at that. Okay. Now, when we start solving, you guys, what I like to do first is I like to set up the fraction that I do have a value for. Okay, so currently I do have a value for my hypotenuse. I don't have values for the x and the y. I don't know what the short leg and the long leg are. Okay? And something I need to point out, you guys, the reason why I can't use Pythagorean theorem on these problems is because I am missing two of the sides. And when we had a 45, 45, 90 triangle, although we were missing two of the sides happen to be congruent. So again, it kind of allowed you to use the Pythagorean theorem. So since we are missing two of the sides of the right triangle and none of the sides are equal, I can't use the Pythagorean theorem to solve for a 30, 60, 90. All right, but anyway, so since the hypotenuse is the side I know, that is the ratio that I'm going to use 2 times to help me solve for x and y. Okay, so the hypotenuse ratio is 2 over the hypotenuse. So I'm going to have 2 over 8, and I'm going to use this to help me find the x and the y. So I'm going to write this bad boy twice. All right, so 2 over 8 will equal, well, on this side, x is the short leg. So I'm going to use the short leg ratio to help me solve for x. So the short leg ratio is 1 over short leg, which in this case is the x. So 1 over x. All right, on this side, y is the long leg, and the ratio for long leg is root 3 over long leg, which happens to be y. Okay, so you use the ratio that you know the value for first, and you use that in each problem to help you solve for the missing side length. So I'm going to use whatever ratio I'm given both times to help me find the other two missing sides. All right, now, before I get started, it's always helpful if you can reduce down your fractions. It will make your life much easier when you're solving. Okay, what's 2 over 8? I know I can divide both of these values by 2. All right, which 2 divided by 2 is 1, and 8 divided by 2 is 4. Okay, so I'm going to rewrite these same ratios using 1/4 instead of 2/8, and that's just simply to make my life easier as I'm solving. It's not wrong to use 2/8. You're just going to get bigger numbers, which will make your life much more difficult while solving. So just keep that in mind. And guess what, you guys? I have a ratio equal to a ratio. So how do we solve when we have a proportion? We cross multiply. You guys already knew. All right, well, let's get started. Okay, so I'm going to start by cross multiplying. I like to do the variable first. So I'm going to do x times 1 is x, and that will equal the other way, which the other way is 4 times 1. And 4 times 1 is 4. So guess what, you guys? The short leg is 4. All right, and guess what? I have another proportion. So I'm going to solve by cross multiplying again. All right, so 1 times y is y, and that will equal the other way. So 4 times root 3. Well, you can't multiply numbers that don't have square roots to numbers that have square roots. So currently, I can't combine those two. So it's just going to be simply 4 root 3. And guess what, you guys? That would be it. So it's really not so bad. And again, if you don't like solving using the ratios, you can still use trig to help you solve, which I'm going to show you how to do that real quickly. All right, now, when you're solving using trig, it doesn't matter which angle you start from. Okay, the only angle you cannot start from is the right angle. So, I don't know. I'm just going to start with 30. Might as well. So I'm going to show you really quickly how to solve for x and y using trig, starting from the 30-degree angle. You could also start from the 60-degree angle and you get the same thing. Okay, so I'm going to start by solving for x first. So x is the side across from my 30-degree angle, so it's the opposite side. A is the hypotenuse. So which trig function has an opposite and a hypotenuse? Well, that would be sine. So I could say sine of 30 degrees equals x over 8. And if I put that over 1, I could cross multiply. So I get x times 1 is x, and that would equal 8 sine of 30. All right, which when I type this in your calculator, don't forget to put your mode in degrees. That's very important. So I'm going to whip out my handy dandy calculator. There we go. All right, let's make sure my mode is in degrees. I am, so we're good to go. Okay, so I'm going to type 8 sine of 30. And look at that, we get 4. So that's another way you can solve. And again, if you want to solve for y, you do the same thing. So I'm going to ignore the x. The y is the side right next to the 30-degree angle, but it is not the hypotenuse, which means it's the adjacent side. You guys already knew. All right, now solving, I'm going to ignore this one for right now. Which trig function has an adjacent and a hypotenuse? You guys are too cool for school. That would be cosine. So we get cosine of 30 degrees equals the adjacent side, which is y, over the hypotenuse, which is 8. And if you cross multiply, again, you get y times 1 is y, and that will equal the other way, which is 8 cosine of 30. And if you solve that, I'm going to show you approximately what 4 root 3 is as a decimal because it will not show up as a radical on your calculator. So I'm going to type 4 square root. Got it this time? Yes. Okay, and that will be, so I'm trying to get about 6.928. So I'm going to type 8 cosine of 30 degrees. Let's see what I get. I hope I get the right thing. Whoa, do you guys see I get the same thing? So again, so we know this is like 6.928, which we know is the same thing as 4 root 3. All right, so if you want to put 4 root 3 in parentheses, you can. All right, so again, after you do the 30, 60, 90 triangles with the ratio, if you do not like using the ratios, you can still use sine, cosine, and tangent. So I'm not going to show you sine, cosine, and tangent on the other problems, but I just wanted to show you guys that you still can use trigonometry to solve since we have a right triangle. Well, there you go, you guys. That's it for example 1. Nice work.